Let's import the PCB file into the project we've created. View each layer in turn. For that, select the Active Layer Only checkbox. There are no wires on the inner layers, only copper areas. Therefore, the layer type for these layers should be changed from Signal to Backup. To do this, open the Design Properties editor, go to the Layers tab and select the type. A message box warns that changing the layer type will cause all wires on the layer to be removed. Go to the Backup Layer Nets tab. There are two copper areas on the internal layer too. Assign two nets to it. Assign the ground net to the internal layer 1. Click the Apply button and notice a warning below in the message bar saying that the VCC-MK net will remain unrouted. This kind of message is always displayed when more than one net is assigned to a backup layer. Next, let's define the routing rules, the wire width and clearances. First, group the wires that are supposed to be the widest. On the Wire Width tab, set their width. Leave the minimal and nominal width equal for the All Nets category. For the custom groups, set the minimal width to 0.2 mm for connection to the narrow microchip pads, and increase the nominal width as needed to 0.8 and 0.5 mm. On the next tab, set the required interwire clearances to 0.25 mm and make the nominal clearance greater than the minimal clearance. Close the Design Properties editor. When routing from scratch, we should first start the Placement editor. That's where preliminary routing happens. Now launch auto routing. A few moments after the start of auto routing, we get a table that contains multiple variants. To select a variant, let's use the rightmost table column, which shows the relative width increase as the number of vias goes down. The recommended value is 25 mm per via, or less. Auto-routing can be stopped manually. It can be difficult to determine when exactly a variant is good enough for routing to be stopped, so the message that says optimization may be stopped is a good hint. If it appears, this means that further optimization may take a long time but produce only slight parameter improvements. When a better variant is found, the hint temporarily disappears. Let's select the variant where there is 8.9 mm per via and switch to the Freestyle editor. See the list of violations below in the message bar. Double-click a message to highlight the violation on the board. Move the component away from the board edge. In Freestyle mode, wires are automatically spread apart while observing their clearance. Run the automatic procedure labeled Start Vias Automatic Movement with Wires Refining. The vias have been spread apart. All online violations have been eliminated. Run DRC check. There are no DRC violations. Next, check net integrity. Let's convert backup layers to signal layers again. Switch to the manual editor. Open the Design Properties editor, go to the Layers tab and select the type. Fill the copper areas. The message bar displays a warning about a net that is not routed. The net is on the edge of a copper area and the via is outside the copper area. Eliminate the net integrity violation. Unpoor the copper areas. Connect the resistor pad to the via that is attached to the copper area. Use the L hotkey to change layers. Remove the extra via. Select a wire segment and press X to select the entire wire. Remove it by pressing Delete. Select the segment of a crossed over wire and move it elsewhere by dragging its markers. Run the start V as automatic movement with wires refining automatic procedure. Some of the vias have been spread apart automatically to use the space that has been freed up. Switch to the manual editor and re-pour the corporate areas. Run DRC. There are no errors. Open DRC settings, select the net integrity and wire width checkboxes and run a check. There are no violations. Save the project.